welcome back to session 2 of K5 Coding Integration in Elementary Grades. And again, I'm Chad Moat. We're going to talk today about computational projects. Just to revisit, last time introduced you to a few tools, some platforms, languages, and introduced you to the computer science website on the DOE at the DOE, which I'm sure you visited before. Lots of resources there, curriculum resources, professional development, and I'm sure those are going to be building over time. So your homework last time was to get a Scratch account and get a username and log in and have a password and have that ready to go. We're going to take a look at that later on, but let's just go ahead and start here. Okay, so basically the idea for this session is that we're going to take one of the practices that's promoted and encouraged by the computer science K-12 frameworks on creating computational artifacts, and we're substituting artifacts for projects, which are basically the same thing. And we all do projects in K5, so this is an opportunity to begin to integrate coding into your existing projects or incorporate projects that are already out there. And the students could learn some programming skills, modify or remix those projects, create their own projects, or it's an opportunity for your students to become familiar with projects that have been created by other students. A lot of times those are very educational. So just to revisit, last time we talked about the K-12 computer science frameworks. I uploaded those documents and gave you links to those. These are practices that were developed by a lot of smart people, including our DOE folks and some practitioners here in Georgia. So Georgia was on the front end of that. And there's a series of practices that they promote and encourage for students from kindergarten through 12th grade. So I'm focusing here on a couple of them, and these are kindergarten through 5. So we're looking at creating computational artifacts, and we're looking at testing and refining those artifacts. So again, artifacts are projects. So just keeping it simple. The other thing we're going to incorporate here is the Computer Science Teachers Association standards for K-12. These are standards that are used nationally, although there are some states that are developing, including Georgia, developing standards for K-8 now. So stay tuned for those. Those are in development. In the meantime, I'm sure that those standards and these standards right here are going to align anyway, but in K2, we're particularly looking at debugging. So identifying and fixing errors in a particular program, or in our case, a project. And then in grades 3 through 5, creating programs, or simple programs, or more complex programs as projects in Scratch, for example, that may have sequences, events, loops, conditionals, those kinds of skills in computer programming. And then another standard, modifying, remixing, or incorporating programs, computer programs, into one's own work. So that's guiding this session today. Just to revisit, remember we talked about code.org actually having curricula that you can start with. In code.org, this is an embedded program, and remember last time I was playing with the Angry Bird, and your students could drag and click some of these visual languages and as blocks. And then when I run this thing, let's see what happens. I went north, east, and then west, and I really didn't go anywhere. So if I go east a few more times, remember our younger kids are learning directions, so this is a great little program to run for them. Oh, he's not going to let me go. I need to take that north out, don't I? I'm going to take the west out too. We're just going to go east for a while. It looks like I'm going to run into some TNT. So this was lesson 6 in code at code.org, so I just wanted to revisit that for you. I like playing this little game, so that was a fun one to play. That's a tool you can use. We also talked about Scratch Junior. Just revisit this for a second. Scratch Junior is a great one for the little ones, ages 5 to 7. And I noticed quite a few schools have iPads and are using those in younger grades, which are great in moderation, using the media in younger grades in moderation. And Scratch Junior is a great one to use. So again, Scratch Junior. I'm going to play this video. I can't remember if I played this last time. Just a video for you to view as a teacher, so you can get more information about Scratch Junior.
Create a new project by looking for the blank page at the top left of your screen with the blue add symbol. All activities ask you to start by selecting a new background. A small thumbnail of the landscape in the top of your screen takes you to the background library. When you've found the background that looks like the one in your activity, simply tap it twice to select it.
So you can see this is just the interface is easy to use for kids. You know, by this point in time, there's been a minute that's passed, they would have clicked all these buttons, and that's okay. You know, getting them just to play around with the interface and choose backgrounds, and then to create from there. And you can see some of the movement blocks and changes with direction. And then there's actually voice or sound. Then you can do series of blocks and more complicated stuff there. And here are some of the sprites or some of the avatars, so to speak. These may be backgrounds. Let's see.
When you selected it, just as with the background, you tap twice. To get rid of the character you no longer need, locate it in the left side of your screen, tap and hold until you see a dancing X. Tap the X to erase it.
So just like on your iPhone, just pressing that button, you can get rid of whatever it is you're trying to get rid of. The kids already know that. Trust me, I've got a 5-year-old. So I would encourage you to play around with Scratch Junior. It's a great little tool for students to use. And I provided a link for you to so that you could think about some animation, multiple characters, making projects, blocks, sharing projects, which is great, learning to communicate, that kind of thing, character lists, scrolling, and then actually pulling in other scripts or characters, and then movement. So one can imagine in the younger grades actually developing a story, some creative writing or storytelling, and lots of cool things there. Science, social studies, all the academics for sure. So let's get out of this. And remember the other tool that I talked about, which is really a programming language and also a platform that holds a very robust coder community. Some people would say maker community, but one of the creators of Scratch, Mr. Resnick, tends to call the community there a coder community because everyone is coding. But remember that Scratch is one of those languages that does translate directly into the Lego Mindstorms and as a fundamental basic foundational language for some of the more complex robots later on. So then you've got the maker aspect of it, connecting code to actual maker tools and sensors and that kind of stuff. So let's just look at this tutorial just for a second. Okay, let's see what we have here. So this is the interface and showing you how to pull scripts out. So here I've got move, point in a direction, drag and move, playing a drum. So this is pulling out sound. I can play, where was the sound? This is a meow. Let's say that I do a meow. And I'm going to play that note for 60 seconds. And then maybe I'll change the tempo, although the meow is pretty annoying. Let's keep that. And then start a dance. So now we have motion. Add another move block. Change Y by 10. Let's go in there and let's change this. See if I can change it by 40. And then do a repeat. So on the control side, I'm going to repeat this. Looks, getting real complicated here. Say hello. Yeah, they're continuing to do that. So that's the idea. And then the control button here, I'm sorry, events. And so when I click my green arrow, my scratch cat takes off. And then notice that it went up in the Y direction by 40. Let's just change this to 5 and see what happens. And there we go. I could have changed this to repeat for 100 times, but I'll spare you that. So just a little tutorial for introducing your students to Scratch. Remember we talked about Scratch being appropriate for ages 8 to 16. My daughter's 5 years old. She's pretty advanced for her age, and she plays around in Scratch pretty well. So, you know, depending on how your kids are doing, how adept they are with the motor aspect, Scratch is definitely appropriate, Scratch Junior, for the younger kids. So today I wanted to introduce you to the Scratch platform, let you be a part of encourage you to be a part of the coder community. One of the things that I always like to do when I'm thinking about projects for classrooms is just to see what MIT has hosting. What's going on in the Scratch world? And the cool thing about this is that they do, let's see if I can find the home page and pull this back up again. Okay, so this was Scratch in Space. So this is Scratch News. And they actually held an event that was called Scratch in Space. And this is what I have pulled up for you. What they often do is these events are connected to some type of research that they're doing. So, you know, that provides a great opportunity for teachers to get involved in research. You're actually on the Scratch Network, it's a tool and a platform and a coder community, but at the same time, MIT is always looking for ways to make it more educational, make the experience more educational, and see how children learn, young people learn in various settings or events, collaborations, competitions, all that good stuff. So it's a chance to be a part of research, or if it's, you know, if it's just an event that's not being researched, to participate in that. And the great thing is that if it's something that MIT is hosting and is behind, there are a lot of activities and ways to connect, and some deep learning that can happen. So this was one of the events that I noticed, and just give you an idea of what they were doing here.
To invite kids from all around the world to create it's Eric from the MIT Scratch team. If you're not familiar with Scratch, Scratch is a visual programming language and online community where people of all ages can create their own stories, games, animations. It's quite cool, and usually people are creating Scratch projects for Earth, so to be played by someone sitting at their computer here on Earth. However, we asked young people in the Scratch online community, what kind of projects would you create for space? And even cooler, what if instead of using the keyboard to play the project, you use your body? So we actually asked this question, and we had an overwhelming response. Hundreds of people submitted projects from over a dozen countries.
Yeah, so I think there is, because I have a microphone in, maybe the video is not as loud as I would like it to be, but that's okay. This is a video that you can look at yourself. So the idea here was they were incorporating motion and webcams, and they had a video of, you saw the one earlier when he was kind of floating around, and then students were responding to this video in ways like maybe here you can see. Let's see if you can see it. So as he's moving, the actual project was coded to follow him. So that was just, one cool thing that they did. And these were the projects that emerged. So they do this a lot. They will, this is part of what they do in the MIT Media Lab is they will host an event, and then they will see what happened. And you can see here that there were over 100 projects that were submitted in this particular event from all over the place. And notice that you have quite a few looking very similar. So what's going on there is that you'll have students that will create a project, and then other students may react to that. So this is happening in schools. It may be happening outside of school. A lot of times students will spend some time on Scratch. That's kind of their social network, so to speak, which I would much rather my child be playing around in Scratch than some of these other places. So, the idea there is that informal learning is much more percentage-wise how students learn the most. I mean, there's some argument that 10% or so occurs from formal education in schools, and the other 90% or so is outside of school. So the more that we can leverage these types of communities so that students are learning, the more that it does support our cause. So this was an event that I would pay attention to those and see what you can make out of it. I chose this one because it was related to space and earth science, which is one of the sciences that we teach in younger grades. So my username is K5 Coding, and you can, if you've logged into the Scratch site, sometimes it's hard to find someone if you're just searching. So this is the link. You'll actually, on whenever you have your user, you're on your profile page, you can it'll show your username, put this behind it, and you can actually see my page. Let's get rid of this. So you can see I joined this page. I created a new one just for the purposes of these sessions 19 hours ago, and I'm able to type I'm a computer science virtual specialist, what I'm working on. I can include a cool picture if I want, upload that, and then I can create projects, share that with the whole Scratch community. I can explore other projects, and this is a studio that I created for this session. So think about your profile page as a virtual classroom. That's one way to think about this. So you have this virtual classroom. Your students can create, they can create their own username and join the network and have their own page. Then they can find you and then they can follow you. So I'm going to just follow myself. And then I can, from here, I can access this stuff more easily. But if you could create a studio, you could think of a studio as a classroom. If you're departmentalized, if you teach all science in 4th grade or 5th grade, then you could have different classes in a studio for each class, or you could have a studio for all of your classes, however you wanted to set that up. If you were a specials teacher and you had kindergarten on Monday and then 1st grade on Tuesday and all the way through 5th grade, then you could have 100 or so different classes. You guys manage a lot, but I think for you could have just a whole kindergarten grade. And then this allows you to, if you're a specials teacher, say that you set this up, then as the academic teachers work with your students in kindergarten, or say 2nd grade, that would probably make more sense, but 2nd grade, then the students could be working on these projects in all of their classes. So during their rotation, if I have a technology class, I'm probably going to do a Scratch project. And then as a specials teacher, I'm going to become the math teachers or the academic teacher's best friend by supporting math instruction in there as well. So I can develop these projects, and pretty much if it's a technology class, I can take off with this, right? And then work collaboratively with my academic folks to incorporate, their academic standards into a coding project. So this is an interface or a way to do that in a way that makes sense. The kids aren't carrying around a universe under their arms and their little trapper keepers anymore, right? They've just got this stored up somewhere and can interact with this project and build it out from there, and it's a portable project. So this was from the one of the projects from the space site, and I just wanted to show this as an example. Let's see. So y'all hear that music? You hear the music? Not that that's important, but it is very loud on my end. Okay. All right. So turn this down just a little bit so it's not destroying my earbuds here. But so I'm going to click the green button, and then I'm just going to scroll in and out. So here's Earth. I used to show this, actually, something like this to my physical science kids, just so they could, realize how small they were in this huge universe, but then how connected everything is. So this shows the kilometers and scrolls out. And there's the orbit of the moon. You guys can, kids can anticipate what's next, right? Earth's orbit, and then we have Mercury, Venus, Mars, the inner planets. Then we have our outer planets. All right. Right over here is Voyager 1, where Voyager 1 is about right now. This is showing, I couldn't tell you what Sedna is, but just the rotation of our solar system, I suppose. And then showing you 1 zillion meters, really big. Here's a cloud, stardust, and then we can see many stars clustering around there. Those are interstellar neighbors, clusters of stars. That's what we can see, 99% of visible objects. Looks like they spelled visible wrong. And then there's the spiral arm. We're actually on the spiral arm somewhere, one of these spiral arms in our galaxy, which is the Milky Way galaxy. And you can see that there are nearby galaxies there. So just a cool little project. It's actually not that complicated. Well, quite complicated, but the sprites, there aren't many sprites. So you can see here that there were only 4 sprites that they included. But this is the code. Now, obviously, this is much more complex than what one would want to do in K5, but just to get your students familiar with the projects and seeing what's out there. And just wanted you to see that you can actually get into the guts of this code, and that's what we're going to talk about a little bit today. Okay. So it looked like a kid may have created that. You know, you're not really seeing the ages of all the people who are creating projects. Sometimes they're younger adults or they're teenagers, and sometimes they're as young as you know, 2nd grade or so. So I showed you. All right, you guys with me? Still with me? All right, good. Okay. So I'm just going to go back to the studio web page. I probably want to keep this open now since it's not wanting to cooperate. So I showed you the universe earth science page project. That was this one, just to bring in some science. Let's talk about life science. So if I am just on the Scratch main page, the home page, I can actually type in, if I'm a science teacher, let's just put digestive system. So the reason why I chose digestive system was for no other reason than I was looking on the winners of the STEM Video Game Challenge this last year, and there was a young girl who I believe was in 5th grade who won, and her project was on the digestive system, and she did it in Scratch. She created it in Scratch. So I wanted to bring that one up. I couldn't find it on the Scratch site. There was a YouTube video of it, and then I found another one instead to show you today. My studio page is not wanting to cooperate. So I searched here on the digestive system, and you can see lots of projects. Who knew that there were so many people interested in stomach acid or the intestines or guts, right? Kids like guts and gore sometimes. But this is out here as a crossword puzzle. So lots of different ones. As a teacher, you want to, you know, if you're just beginning with Scratch, having your students navigate, and maybe you have a particular topic that you're covering, go out and find a project and put it on your studio, and then have the kids play it. Get them interested in Scratch, right? Getting them more used to the coder community, getting them used to being able to download a project, to play a project, to look inside and see what the code is, how the code's arranged, how it was programmed. That's always a great experience for the students. And then, you know, they can also get used to understanding how to provide feedback to particular projects they like. One of the standards for computer science for the younger kids is communication. Well, for all students actually, communication, but at the younger level, you know, communicating in places that are safe, right? So Scratch is a site that I would argue is as safe as any that's even monitored at the school level, because there are counselors in the network. The community works to manage its own norms, and also the site is for public education and is monitored by the MIT Media Lab, and, you know, by a lot of the fancy programs that they write to ensure that Scratch is a safe place for students to thrive. So I would definitely argue that the Scratch network is one of those places. So just going to this particular project, this is Race to the Digestive System. I know this is created by a student, and I'll show you why. You can see this. So looks like a bug and a potato chip. And following the route that food takes when one eats, so this is the esophagus. This is how you know students made this. I never liked you since we met. Now give me your money. So I take this very in jest, and just kind of a way that these two little characters are interacting, and now they're in a little competition in answering questions. They're going to have this banter back and forth and asking about the digestive system. So type 1 if you think the answer is that your stomach breaks down food. I think this is the role of stomach acid. Or it's a place to swim in. I'm going to say it's a place to swim in. Sounds likely. Ah, I was wrong. Stomach acid breaks down food. So now they're moving along, going out of the stomach, moving through the small intestine. It's a question for the folks in the audience. How long is the small intestines, alimentary canal? I missed this one yesterday. I thought it was around 30 feet or so, but I don't know how many meters that is. I'm going to say 7, maybe 3 feet in a meter. Ah, missed it again. That's what I put. Okay, so it looks like there was a glitch in that one. So, I mean, you know, there were a few things that told me that a younger student made this one. One was the banter back and forth of give me your money, and then no, and then, well, let's play a game of going back and forth on some digestive trivia. And the other piece that would tell me that is there was quite a delay in the number of seconds between answering and stopping and those kinds of things. So just the processing of information may be a little slower there. So it was probably a younger student. This is the code, still quite complicated, but it could be that the students were, this is the beetle, this is the sprite 1, sprite 2, there's the Bruce. When I click this, say my name is Bruce, say my favorite for 2 seconds, my favorite food is potato soup, say yum potato soup, and then broadcast the message. So here's the backdrop. You can see how it switches. There are 9 different backdrops there. So let's go back here. Well, you can actually remix this, and we'll do some of that in a minute, but that's probably what happened here, although I can actually find that out. I'm going to go to the project page, and then here's the remix tree. This one actually hasn't been remixed at all. So if it had been remixed quite a few times, there would be lots of branches going out. So we'll look at the other projects to see what kind of remixing has been going on there. Okay, let's go back. But just here was the costumes I wanted to show you. I can, just like paint, I can actually go in and alter this and change some things, put some color on it, that kind of thing, if I'm remixing it. So this save changes, and as a student I can go in and manipulate these different sprites, change things in it. Okay, so there's an example of a life science project, although I don't want to do that. That's a more complicated project, so we'll look to what you'll want to do is, as we move forward with the sessions, we'll look at some of the coding skills that you'll need as a teacher to help students along in these to build projects. If you remember, there's a Scratch curriculum, basically a whole book that you can download, and I showed you that last time, that has lots of different activities and shows step by step some of those activities that students could get involved in and build. And they actually have in there, they have some of the age ranges, but you know, I've worked with students in 2nd grade and 8th grade, and you know, the 8th graders can do a lot more complicated code, but some of the basic features are the same. And so with the younger kids, they can get started with something very simple, and that's the great thing about Scratch, is they describe it as a low floor, high ceiling. So it's easy to get started, and then what one could do with the coding language is create some very, very cool projects. So this is a project that I was thinking about just in browsing yesterday in English language arts, and how I could incorporate something like this in my classroom. So here, you know, we've all seen Charlie Brown Christmas. This was an impressive project.
Nobody sent me a Christmas card today. I almost wish there weren't a holiday season. I know nobody likes me. Why do we have to have a holiday season to emphasize it? Thanks for the Christmas card you sent me, Violet. I didn't send you a Christmas card, Charlie Brown. Don't you know sarcasm when you hear it?
I'm going to bust my speakers if I turn this up much louder. So what intrigued me about this project was they really went through and basically mimicked the cartoon, right? We see this at Christmas time, or you know, throughout the year. It's something that students are familiar with, and then they, from start to finish, this was a project that mimicked and reflected and basically recreated that movie. But one could imagine in English language arts, with some of the digital storytelling that can be incorporated, this would be something along those lines, not creating the Charlie Brown Christmas, but having a background, having a sprite or a character, and then in 1st grade or kindergarten, even 2nd grade, the students begin to write, you know, could be cause and effect, showing them this particular, this intro and the hello in there. Stopping there, right? And then asking students, what is the character saying rats for? Why was the character so interested in what was in the mail? And then creating something from there. And that is actually a very simple project that an ELA teacher could begin for the class, and then over time the students add to that, incorporating new characters, which in Scratch, these characters are readily available. These, they actually use Paint or something like that to create them. But there's a list of characters, or a whole smorgasbord of characters that one could pull in and begin to tell a story. So, and you noticed in the other project, this one, at the beginning, my name is Bruce. My favorite food is potato soup. So I'm going to go to Bruce and look inside again. And you can see here that the students can, I'm going to say, my name is Chad. Voila, my name is Chad. So getting students started with text is often a great way to start coding for the younger students, because they're not necessarily knowing what all of this is yet. But as they begin to interact with this and interact with the project, I say my favorite food is chocolate chip cookies. And as the students begin to interact with the text, again, I'm stressing ELA right now, then they begin to see the cause and effect and the chain of events in the code. So my favorite food is chocolate chip cookies. So students love when they're beginning to learn how to write, and they're beginning to use letters and put nonsense words together, which is, as teachers of younger children understand, that's important for phonics. Pull in a project and have the kids play around with the text. And it's one of those things that could be done as an activity just as quickly as pulling out paper and pencil. In my mind. And over time, you can have ones that you pull in and they're there for you. It's stored. It's a project you can pull up. Kids are in a lab or they're in the classroom, and they can begin to manipulate this text and the code. They can begin to manipulate the code too. So now I've pulled out the introduction and the show, and when I click this, let's pull this here. Then it goes straight to my favorite food is chocolate chip cookies. So, example of how you can use ELA. Now, obviously, you could create some really advanced stories. You can have characters and dialogue and change backgrounds and those kinds of things, which we'll show you over time. Just giving you a synopsis of some of the things that are out there. 2 projects that I wanted to bring up. And we'll be done in 2 minutes, folks. Bear with me. Just to show you that these are similar projects, but a little different. So here, I'm going to take a quiz. My cat goes there. Remember earlier I was showing you how to move the cat? And then the question is, what continent am I on? Use the capital letter. So that's North America. So it actually doesn't doesn't matter if I do capital or not. And then it is correct. And this one, where is Africa? Here I point and click. So I bring that up just to show you how the programming language can be quite different for something that is very similar in nature. Although here this is recall, right? And this is recognition of the location. So for geography, something to think about. Geography is very easy to do in Scratch because you have movement and location and point and click, and then answering questions or creating stories around geography as backgrounds is something that is very low floor. Mathematics. This was actually a project created by an 8th grade student in the 2012 STEM Video Game Challenge. These are all constructionist games where the students are creating their own games. Here, it's interesting that they all look very similar, but that's a topic for another time. Let's do level 1. 2 plus 5. Whoa, I gotta work fast. 7. And then it determines which way the car is going. 3 plus 3. Woo! Change that. So that's a project that could be downloaded, and one can change some of these numbers up, have the kids manipulate and remix these for math. I chose learn the continents earlier because I did want you to see inside these. This one actually. So this is a project that could be easily remixed here because I have some repeats, and then I have North America, South America, Africa, Europe, and Asia, and Australia, and Antarctica. So here I can begin to see how this code is related to the cat, this sprite, and what happens when that cat does stuff. And as students begin to manipulate this code, they can begin to understand it much more. And then my final thought for that would be for, as a starting point, having kids looking at projects that support your standards, getting with a specialist teacher to see how they can incorporate their particular subject in with these projects, and have the kids download and remix just some games that are low floor for them to play. And then over time, the students can begin to create projects from scratch. No pun intended. Did want to show you, just going back to my profile page. I'm following the studio, and this is my studio. So I would encourage you to go into this studio, follow me and follow this studio, and as we over time develop projects, use projects, and we can put these in. I've pulled this down. You can see the remix tree here, how this has been. We don't call this cheating in Scratch, we call it remixing, and we give them credit for it. And then we can begin to have some interaction here. So that is what I wanted to talk about today. Next time, we're going to get back into Scratch and begin to look at ways to leverage this community for learning. Thank you.